Last week we looked at how to add two forces together using the graphical method, going parallelogram or tip to tail. What if you have more than two forces? What if you have three of them? That's no problem. You can still do the same method. So let's look at how we can do that. You could do the parallelogram, but it's a big pain, and I don't recommend it. Nobody does parallelogram when you've got three forces, because you have to add two of them together, find the diagonal, then take that one, add it to the other one, find that diagonal. It just doesn't work. So forget parallelogram. Let's think about tip to tail. And with the tip to tail method, you can just stick all three forces together. Tip to tail, tip to tail, tip to tail, all at once, and then connect them with the resultant arrow, and there's your answer. And just like before, you can do them in any order. Here's an example out of our book with here are three forces here. He has strung them together, A, B, and C. There's the resultant. Then he tried, okay, how about B, C, A? You still get the same resultant. It's kind of funny shape, but it's still the same length and angle. Or then he tried, how about CBA? Still the same resultant. So you don't have to worry about which one to do first or second. Just stick them together. So let's take this order. You draw the forces, as he's done up at the top, and then you stick them together tip to tail. The tip of one arrow sticks onto the tail of the next arrow. And now think about where you started that string of three forces. There's a start point where you started, then you went around this loop, and there's an end point where you end. That's how you know where to put your resultant arrow. You start at the start point, you head off toward the end point, and that tells you what direction your arrow points. You point from start going off to end. There's your resultant. Here's another example of three forces. And again, we could stick them together in any order we want to, and we'll get the same resultant, same length, same angle of force. So let's stick them together in, we'll just pick this order. Tip to tail, tip to tail. Now, notice where you started. There's the start point. Then you went tip to tail around this loop, and there's the end point. That's where you ended. So you're going to draw your resultant from the start up to the end, and there it is. The resultant starts at the start point and points to the end point, and there's your arrow. Here's one that has 5 different forces, all different lengths. And I just tried sticking them together in 5 different kinds of orders. And look, even though the squiggly polygons look different, the resultant is the same arrow in every single case. Same length, same angle. Here's an example out of the book. We have 3 forces. He gives us the size and the angle, so he tried sticking them together, tip to tail, tip to tail. Then he started at the start point and headed off to the end point. And you notice it's sometimes hard to predict what direction that resultant is going to go. But in this case, this is showing us that with this steel connection, the result of those 3 forces happens to be a force that is just a little bit below horizontal, pulling off to the right. That's the net result of those 3 forces. Let's look at the 2 problems that we're going to do in this next assignment, and we'll go over and we'll look at doing one of these in CAD. So here's one, the first problem. Now you notice it says KN. So these are metric. Newton is the metric equivalent of force. And if you're interested, a Newton is about 1/4 of a pound. And the way I think about remembering this is I think about, okay, Newton, fig Newtons. Fig Newtons are cookies. And then you go to the produce section at the grocery store and there are some figs there. So I went from Newtons to fig Newtons to figs, and in the produce section a fig weighs about 1/4 of a pound. So that's my memory trick for remembering, okay, there are about 4 newtons in a pound. If you care, you might not. Now what about this K thing? K, you might recall from elsewhere in life, K stands for 1,000. It's kilo, so kilo is 1,000. And so when he says 6 kilonewtons, that means this is actually 6,000 newtons. Well, you probably will want to just draw your arrow 6 things long. Those units are kilonewtons, and your answer will be in kilonewtons. And I've put the answer at the bottom of the slide here. Your resultant should turn out to be about 10.2 kilonewtons, 10.2 things long, and it should turn out to be about -5 degrees. So in other words, it's going to be just a little bit below the horizon line. Here's the second problem. It's also metric, so it's also got kilonewtons. Now we have one force, 1 kilonewton pulling up and to the left, one that's up and to the right, and those two, he doesn't give us angles, he gives us rise over run. And then here's one where he gives us degrees. And when you string those 3 together, tip to tail, you will come out with, I'm giving you a range here because the answer key in our book and various ones of us who've stuck these together have come up with differing answers. So if you are somewhere in the range between 3.4 to 3.656, that's about the right range. And the angle will be somewhere between 52 to 56 degrees. So let's go look at these in CAD.